All right, this is an example from our module 4 material, the equilibrium module. We've got a standard Gibbs free energy of reaction given. Everybody's number is going to be a little different. You'll notice it's written in scientific notation. That's just so with the programming of the question, I can get your answer in scientific notation. It's a little quirk of our learning management system. I'm going to rewrite this as 380, that is kilojoules. It might be presented as kilojoules per mole, but 3.8 times 10 to the 2 is 380. We're at 298 Kelvin, and I'm looking for the equilibrium constant K. That's a large K. Of course, you know that the equation that relates the two is delta G equals minus RT, natural log of K. We do have to use logs and inverse logs here, and we're trying to solve for K in this case, and it's inside the log. I have found mathematically it's easier for me if I go ahead and first solve for the natural log of K, and then I'll take the inverse log to get K by itself. To get the natural log of K by itself, I want to divide both sides by negative RT so that they cancel on this side. So I'm left with negative delta G over RT. And then I'll plug in my values. R is a constant. It is the ideal gas constant, but in units of joules. And it is joules per Kelvin per mole. Again, that per mole, you may or may not see it. Don't get too worried if it doesn't cancel. So we have R in joules. We have delta G in kilojoules. I'm going to have to change one or the other. It doesn't matter which one you change. I'm going to change kilojoules to joules just because that's easier. So I have negative delta G, that's 380 times 1,000, or 10 to the third. And that gets it to joules. Kilojoules to joules conversion is absolutely something you should remember from Chem 1, or you can review it. Divided by that 8.314, which is in joules per Kelvin, and the 298 Kelvin is down there in the bottom as well, the temperature. I'm going to plug all of this in my calculator to get an answer. So you should be punching it in as we go through this to make sure that you get the same thing that I do. I'm just plugging in I'm plugging in as I walk through this 380. I am using that EE button, the scientific notation button on my calculator. So I punch in 380 EE3 divided by 8.314 divided by 298 equals. That way I don't have to use any parentheses. I do need to make it negative, and I end up with a negative 153.375 ... Don't round it, especially if you've got an equation with logs in it. If you round in the middle, you're going to get the wrong answer. Depending on how close you are, you may or may not get partial credit. You won't get any credit on a practice set. On quizzes and exams, I go back in and I look for sig fig or rounding errors, and I give partial credit as long as you're really close. But you want full credit, so don't round. I've got this number sitting there on my calculator. It is the natural log of K, so to get K by itself, I take the inverse natural log of that number that's sitting there on my calculator. On my calculator, I don't have a graphing calculator. I have a cheap calculator. So I have to make sure the number is sitting in my screen, and then I take the inverse log of it, or the second function, natural log. If you've got a graphing calculator, you do punch the inverse log first, the second function of the ln log, and then you can bring that number back up from the memory stored in your calculator to get the inverse log of it. And when I punch that on my calculator, I get 2.4528 ... times 10 to the negative 67. I do want to do a quick check. The delta G was positive, which means this is not spontaneous. And in our equilibrium module, we learned that a number that is less than 1, also indicates not spontaneous. This is a very small number. It's not spontaneous. That matches with the delta G. That's just a quick way to make sure I haven't made a sign error. And then my instructions are to round my answer to 2 sig figs. So I will call that 2.5 times 10 to the minus 67. And there's a place for me to type in the 2.5 and the negative 67. I hope that helps.